In today's lesson, we're going to be looking at how to add fractions with unlike denominators. You will need a copy of today's notes, which is 2 pages, and then it's helpful if you have a blue and red colored pencil or crayon, or I guess you could use marker, because I am going to color code these problems as we go through them. If you don't have those coloring supplies, it's okay, just a pencil will suffice. All we're going to be looking at today is the notes. You don't have any additional assignments today except for to watch this video and follow along. And we're only going to do the first 5 problems together. 6, 7, and 8 will be in a separate video for you to view tomorrow. So as I said, today we're going to be looking at adding fractions with unlike denominators, meaning the denominators are not the same. Before we do that, though, I want to review what we did before break about adding fractions with like denominators. So here's one that, like we did before break, where the fractions have the same denominator. So in other words, both of those fractions come out of pizzas where the pieces are the same side. This is divided into fifths, and this is divided into fifths. And all we have to do then is just combine the pieces together. So we'll take the red piece and the 2 blue pieces, combine them into one fraction, and we can see that we have 3/5 total. Remember, the denominator stays the same. That's the size of the pieces, so we don't change that, we just rewrite it. And then it's only those numerators that we add together. So those were super easy problems. When we go ahead and look at adding fractions with unlike denominators, right away we're going to run into a problem. When the denominators are different, this means that the pieces are different sizes. So thirds are a different size than fourths. And let's see what actually happens when you try to add those together. So here's my 1/3. I'm going to bring that down here. And then I'm going to try to add 1/4 to it. And when I try to combine the 2 of them, I might be able to draw them next to one another, but I run into this problem of having no way of really recording that fraction. I can put them like that, but there's no mathematically accurate way to describe that. So in other words, you can't add or subtract different size pieces and have an answer that you can describe because the pieces are different sizes. This really isn't any kind of fraction we can write down on paper as an answer. So because that's our problem, we're going to have to do some extra steps with problems like this to solve that. The solution is when the denominators are different, you must first find a common denominator. In other words, I'm going to take thirds and fourths and find something that's equal to each of them, something equal to a third, something equal to the fourth, where the fractions have the same denominator. And once we've done that, then we can go back and do that really easy step of just adding and subtracting. So it's going to take us 3 steps to get these fractions to have equivalent or have the same denominator. And once we've done all that, then it can become one of those easy problems like we just looked at. So here's step 1 of this process. Step 1 is to find the LCM, or least common multiple, of the denominators. So let's review how to do that. My 2 fractions are 1/3 and 1/4. And again, what I'm going to try to do is get them to have the same denominator, meaning the pieces will be the same size. So I'm going to be looking at those denominators of 3 and 4, the denominators, and I'm going to be listing multiples of each one. So as I do that, what I'm doing, and I'll give you a picture here over here of what's going on, is that I am taking this thirds and I'm dividing it into more pieces and keeping it equal. And as I'm looking at this, again, as I'm listing those denominators, these are other fractions that are equal to 1/3. So all of these are ways to make an equivalent fraction that's equal to 1/3 using a different denominator. Let's try this with a fourth. We can use 8ths, and notice how those are equal. We could try 12ths, and again, that's equal to a fourth. Or we could keep going and do 16ths and 20ths, and we can keep going, but our goal here is to find the smallest one where the denominator will work for both of them. So in this case, it is 12, and that's our least common multiple. And just to picture what we're doing then, what we did was find fractions that were equal to a third, fractions that are equal to the fourth, and pick the smallest one that has the same denominator between the 2 of them. So now we've got pieces that are the same size that we can add. So again, in step 2, going back to your notes, we're going to use that LCM as the common denominator. So our LCM was 12. And so we're going to take 1/3 and equal it to something out of 12, and 1/4 and find the equivalent fraction out of 12. So step 3 is to find our missing numerators. Remember, we do that by figuring out 3 times what gives me 12 times 4. So I'm going to multiply the top by 4 to keep it equivalent. 1 times 4 is 4, and that's what 4/12 looks like. So again, as we shade that, you can see that 4/12 is the same thing as 1/3. So we're using the exact same amount, we're just writing it with a different number of pieces. And then over here for 1/4, 4 times what gives me 12? That's times 3. I'll multiply the top times 3. 1 times 3 is 3. And that's what 3/12 looks like. So again, you can see that 3/12 is equivalent to 1/4. And so now we have fractions that are equal to our starting fractions. So we haven't changed the value of either of them, but our denominators are now the same. And that leads us to step 4, the easy part. After we've done all that work, we're just going to add those equivalent fractions, which means we're going to shade in and color the 4/12. And then we'll also shade in the 3/12 that came from this blue fraction. And when we do that, when we combine them all together, we end up with a total of 7/12 altogether. Let's take a look at problem number 2. We're going to add together 3/4 and 1/6. And again, the way they are right now, I can't combine them because the pieces are different sizes. So I'm going to have to go ahead and get a common denominator by first finding the LCM of the denominators. So my first denominator here is 4, and this one is 6. I'm going to go ahead and count by 4s, 4, 8, 12. Count by 6s, 6, 12, 18. And the least common multiple is 12. So that's going to be the denominator that will work, that I can find something equal to it out of 4 and something equal to it out of 6. So step 2 is to use that LCM as the common denominator. So I'm going to set them both equal to 12. Step 3, I'm going to find those missing numerators. So 4 times what gives me 12? Times 3. 3 times what gives me 12? Times 3 equals 9 altogether. And so 9/12 looks like that. And so you can see 9/12 is equivalent to 3/4. I'm not changing the value of it. I'm just changing how I'm writing those pieces. 1/6 into 12. 6 times what gives me 12? 2. On the top, I'm going to multiply by 2 as well. So I get 2/12, and that's what it looks like. And again, you can see that that one is equal to 1/6. So the value is the same. Now that I've done all of that work, my last step is the easy one. I'm just going to add them together. So I'll shade in 9 pieces, and then shade in another 2. And that gives me 9 plus 2, gives me 11/12 as my final answer for that problem. If I'm going too fast for you, remember that you can pause the video, rewind it, however you need to control the speed so that you can follow along. Take a look at number 3. Whoops, there we go. Number 3 is adding 2/3 plus 1/9. So again, my first step is to find the LCM of the denominators. So I'm going to list multiples of 3 and multiples of 9. And multiply by 3, I get 3, 6, 9. Multiplying by 9, 9, 18, 27. And remember we talked about with the LCM, sometimes that larger of the denominators is actually the common denominator. So if I was counting by 3s, I could go all the way out to 18, but be careful, make sure you're always trying to find the smallest one that's the same. And many times, not always, but sometimes it can be that larger of the two numbers that's your LCM. So LCM is 9, and now step 2, we're going to use that LCM as the common denominator. So I know I can take 2/3 and turn it into something equivalent out of 9, and of course, obviously I can use 9 here. So let's go ahead and step 3, find those missing numerators. So 3 times what gives me 9? Times 3. So on the top I'll multiply by 3 as well, and that gives me 6/9. So 2/3 is equivalent to 6/9. Notice how they're equal. And then of course this is 1/9. It's already equal to that. So I mean I can write out that I'm multiplying by 1, but I really don't have to. It's the same exact fraction. So 1/9 is equal to 1/9. So now I've done all those 3 steps to get the denominators the same. Now all I have to do is go ahead and add them up. So I'm going to take my 6/9, same thing as 2/3, and color those in down below. and then I'll go ahead and shade in my 1/9, and I'm combining them together, adding them together, and 6 plus 1 gives me 7. Denominator is 9, so my final answer is 7/9. Let's go ahead and take a look at problem number 5. Hopefully this is getting to be a pretty easy routine. I know there's a lot of steps, but it's going to be the same thing every time. So here we're going to try to add together 1/6 and 1/2. And so our first step is to find the LCM. So of the denominators. Remember, always work with those denominators. So it's the 6 from the first fraction and the 2 from the second. I'm going to list multiples of 6 and multiples of 2. And I warned you again to be careful to make sure you're always picking the smallest one. The LCM is not 12 here. There's actually one smaller than that. It's 6 because 2, when I multiply by 2, I can end up with 6. So sometimes that will work out that the denominator of the larger fraction is actually one that you can use as the equivalent. So LCM is 6. And so step 2 is to use the LCM as the common denominator. So I'm going to try to rewrite both of these fractions with 6 as the denominator. Step 3 is to find the missing numerators. So 6 times what gives me 6? That one's already been done for me. It's the same exact fraction, 1/6. 1/2, 2 times what gives me 6 times 3. So on the top, multiply by 3, and that gives me 3/6. So 1/2 is equal to 3/6. So now I have the denominators the same. I'm using fractions that are equal to my starting fraction, so I'm not changing the value of it, and I just have to combine them together for step 4. I'm going to add those equivalent fractions, 3/6, and add one more to it, and my answer is 4/6. And there is one more step I'm going to throw in there for this problem. Sometimes when you add them together, you're going to get an answer that's not simplified. So sometimes there is a 5th step here, which is to simplify them if you can. So there's actually a simpler way to write 4/6. Remember, when we're simplifying, this is the one where we use the greatest common factor. So we're going to use both the numerator and denominator and find the factors of both. Remember, those factors are the numbers we multiply together to give us that number as its answer. So 1 times 4 and 2 times 2 are factors of 4. Factors of 6 are 1 times 6 and 2 times 3. Then I'm going to circle the greatest common factor to simplify it, which means it's the largest number I can divide both the numerator and denominator into. So I'm going to divide both of them by 2 in this case is the greatest common factor. And when I do that, 4 divided by 2 is 2, 6 divided by 2 is 3, and so 4/6 is equivalent to 2/3. And you can see how 2/3 has the same value as 4/6, and that final answer then to this whole problem then would be 2/3. Good job today. If you need to rewatch any part of this video, go ahead and do that again. I know that there's a lot of steps to it and it can be a little confusing. We're going to keep practicing this. Tomorrow you'll watch a second video where we'll finish the last 3 problems, and then you'll start working on a worksheet to practice the skill.